Okay, so here is the practice test that you got. I don't even know what day it is today, that you got yesterday. I'll just say that. And so, what I'm going to do is I'm going to walk you through the practice test, explain the answers, and then if you still have questions or you just want to come and chat and hang out, I'll have a Zoom call later today that you can get on and ask questions, get further clarification, etc. But first line of business would be to go through, check your answers with the PDF, and then come to this video and see if my explanation here makes sense for you. Okay, excuse me. Let's look at this first section. It says, Mrs. McAnally polled her students to see what their favorite flavor of ice cream is. The results are to the right. Okay, so there were 50 people total. So what is the probability that someone picked chocolate? Okay, well that would be 12 out of 50. Okay, use your calculator if you need to. Don't try to do it all by mental math, but I can simplify this by dividing both by 2, and the simplest form would be 6 over 25, right? The probability that someone picked chocolate is 6 over 25. What's the probability that someone picked cookie dough? Well, that's 8 out of 50. Okay, well, I can divide both of those by 2, and I'll get 4 out of 25. And then what's the probability that it's strawberry or vanilla? If you add those two together, it's 30. So 30 out of 50, those are both divisible by 10, and you get 3 out of 5. And then what's the probability that someone picked something that's not vanilla? Well, if 16 are vanilla, that means 34 are not. So 34 out of 50, we would divide it by 2, and that's 17 out of 25. Okay, basic probabilities, simplest form, the end. Okay, next is counting principle. That's where we're going to multiply our choices together. So it says, Zach is deciding on what he wants for dinner. His mom gave him 3 choices of entree, 4 choices of sides, and 3 choices for dessert. How many different meals or dinners could he have? So he has 3 times 4 times 3, which would be 36. Okay, Lauren is trying to decide what to wear to her gymnastics competition. She has 5 different leotards, 5 pairs of shorts, and 3 pairs of tights. So 5 times 5 is 25, times 3 is 75. And again, use your calculator if you need to. It's absolutely fine. Okay, number 7. Mason is buying a new bicycle. There are 8 different sizes and 5 different colors. How many bikes can he choose from? Let me fix this. Okay, there we go. So 8 times 5 would be 40. You can choose from 40 different bikes. Okay, number 8. When it's a factorial, that means that we are starting on that number and multiplying all the way down to 1. So 3 times 2 times 1 is 6. Okay, another example of a factorial would be this one, number 11. 7 times 6 times 5 times 4 times 3 times 2 times 1. And by all means, use your calculator. And it's 5,040. Okay, that's a factorial. The next thing we learned about were called permutations. Okay, that's where the order matters. So how many ways can we arrange first, second, and third place? How many ways can I pick my top 2 people? That kind of thing. And so that would be like number 10, where it's 8p2. So we start on 8. We're making 2 choices. So 8 times 7 is 56. Okay, or on number 12, 9p5. That means we're starting on 9, and we're making 5 choices. So 9 times 8 times 7 times 6 times 5 is 15,120. Whoops, that looks like a 6. Okay, and I don't expect you to have all this written out. I'm just trying to, again, walk you through how I'm getting these answers. And then the very last one are combinations. And combinations are when the order doesn't matter. So we have to get rid of duplicates. So I think on your notes it was like raisins, granolas, blueberries are the same as blueberries, granola, raisins, right? It doesn't matter what order we pick them in, it's the same. So to do that, we do the permutation. So like here, 6 times 5 divided by the factorial of that second number. So that would be 30 divided by 2 is 15. Okay, here's 7, 6, 5 divided by 3 times 2 times 1. 3 times 2 times 1 is 6. 6 and 6 cancel. 7 times 5 is 35. Okay, and again, use your calculator if that's helpful. Okay, number 14. Find each probability. In his lunchbox, Sam has 5 Twix bars, excuse me, 3 Snickers bars, 4 Crunch bars, and 3 Milky Ways. He reaches in, picks a candy bar, eats it, and then picks another. Find each probability. So the first thing we need to know is how many are there total? So 5, 8, 12, 15. Okay, so what are the chances that Sam reaches in and picks out a Twix? Well, that would be 5 out of 15. Okay, and now there's only going to be 14 candy bars left because he ate a Twix bar. So how many are Snickers? 3 out of 14. So what we can do is we can go ahead and cross reduce or just simplify our fractions. So like this one, 5 over 15 is going to become 1 over 3 because 5 goes into 5 one time and into 15 3 times. And then look, I can even reduce again. 3 goes into 3 one time. So all that's left on the top is 1 times 1 is 1. And on the bottom, all that's left is 14. So that would be my answer. Okay, if that confused you, then you can go ahead and multiply all the way across. You would get 15 over 15 times 14 is 210, and then you'd have to simplify, but you're going to end up with the same answer. Okay, number 15. What are the chances that his first pick is a Snickers bar? So we're starting over. Okay, there's 3 out of 15 are Snickers. So now there's 14 left. How many are Milky Ways? 3 are Milky Ways. This is the exact, oh no, it's not. I thought I was doing the same problem again. Okay, 3 of them are Milky Ways. So I'm going to go ahead and I'm going to simplify this fraction. 3 and 15 can become 1 over 5. Okay, I can't simplify this anymore. Nothing cross reduces. So now 1 times 3 is 3. 5 times 14 is 70. And that would be my answer. Okay, number 16, what's the probability that he picks 2 Crunch bars in a row? So the chances that the first one is a Crunch is 4 over 15. Okay, now there's only 14 left. And how many of them are Crunch bars? Only 3 of them, because he already ate one. So let's see what we can simplify. 4 and 14 are both divisible by 2, and that's going to become 2 and 7. And then 3 and 15 are both divisible by 3, and that's going to become 1 and 5. So now we get 2 times 1 is 2, 5 times 7 is 35. And that's my answer. On number 17, what's the probability that he picks anything other than a Twix? Well, that's 10 out of 15, right? 5 of them were Twix, so 10 were not. And then what's the probability that the next one is a Crunch bar? Well, that would be 4 out of 14. So I'm going to go ahead and simplify this and make it 2 out of 3 because they're both divisible by 5. And these are both divisible by 2 and become 2 over 7. So now when I multiply across, 2 times 2 is 4. 3 times 7 is 21. So 4 over 21. Okay, let's look at the next page. Tell whether each situation would represent an independent or dependent probability. So independent means that one does not affect the other. So if you roll a dice and I roll a 3, does it decrease my chances of getting a 3 next time? No. So these are independent, right? It does not affect the second roll what you get on the first. Number 19, if you pick a cookie, eat it, and then pick another, that would be dependent, right? If there's half, let's say there's 3 cookies, D-E-P-E-N-D-E-N-T, okay, and there's 2 chocolate chip and 1 sugar. If I eat the sugar cookie, did that affect your chances of getting a sugar cookie when you got to pick? For sure. So that makes it dependent. Okay, let's look at number 20. A bowl of fruit is on the table. It contains 3 apples, 3 oranges, and 4 bananas. Ryan and Jack come home from school and randomly each grab 1 fruit. What is the probability that Ryan grabs an apple and Jack grabs a banana? Okay, so first Ryan is grabbing an apple. So there are 10 total, right? And 3 out of 10 are apples. Well, now there's only 9 left for Jack. So what's the chance that Jack grabs a banana? That's 4 out of 9. So now I'm going to cross reduce 3 and 9 are both divisible by 3. That becomes 1 and 3. 4 and 10 are both divisible by 2. That becomes 2 and 5. So now when I multiply across the top, 1 times 2 is 2. 5 times 3 is 15. Okay, and then let's look at 21. The game of backgammon uses 2 standard dice, each with the numbers 1 through 6. You need to roll double 3s to win the game. What's the probability that you will get that result on your next roll? Okay, so what are the chances that we roll the first dice and get a 3? 1 out of 6, because there's only 1 3 on the dice. So now I roll my second dice. What's the chance that I get a 3? It's still 1 out of 6, or it's 1 out of 6 again. So 1 out of 36. Okay, and again, this represents a dependent situation, right? What Jack had left to pick from depended on what Ryan picked first. These were independent. It didn't matter what my first roll was. That didn't affect my chances of getting a 3 on the second. Okay, down here, it says you are playing a game with Miss McAnally, and before you take your turn, you get to spin the spinner shown below, okay, which is right here, and then you roll a dice. Find each probability, write your answer as a simplified fraction. So what is the probability that you get a red? Well, that's 1 out of 5. Then on a dice, what's the probability that you get an even number? Half of them are even. So 1 over 5 times 1 over 2 is 1 over 10. Okay, now what's the chance that I get a red or a green? Well, that's 2 out of 5. And then how many numbers on a dice are a 6? 1. Okay, I can go ahead and cross reduce. 2 and 6 are both divisible by 2. Those become 1 and 3. So now I have 1 times 1 is 1. 5 times 3 is 15. Number 24, what is the chance that I spin my spinner and get anything that's not green? Well, that's 4 out of 5. And then what's the chance that I roll my dice and get an even? That's a half. I'm going to cross reduce. 4 and 2 are both divisible by 2. And so what that leaves me with, 2 times 1 is 2. 5 times 1 is 5. Okay, and then down here, what's the probability that I get a yellow? 1 out of 5. And then a 2. 1 out of 6. So when I multiply that, I get 1 times 1 is 1. 5 times 6 is 30. Okay, what are the chances that I spin my spinner? I'm on this one that doesn't have a number. What would be 26? And get anything that's not yellow? Well, there are 4 out of 5 that are not yellow. And then how many on my dice are a 5? 1 out of 6. I'm going to cross reduce. These are both divisible by 2. That becomes 2 and 3. 2 times 1 is 2. 5 times 3 is 15. Okay, what are the chances that I get a red, an orange, or a yellow? Well, that's 3 out of 5. And then a 1 on a dice, 1 out of 6. I'm going to reduce 1 and 2 because they're both divisible by 3. 1 times 1 is 1. 5 times 2 is 10. Okay, number 28 says there are 15 kids in our class and I'm making groups of 4. How many different groups of 4 can I make? Okay, so does it matter if I pick, let me think, like Caleb, Avery, Elijah, and Isaiah? Or Isaiah, Elijah, Avery, Caleb? It didn't matter what order I picked them in, right? They're all in the same group. So that indicates to me that this is a combination problem. Okay, the order that I'm picking them in doesn't matter. I have 15 students, I'm choosing 4. So 15, 14, 13, 12 over the factorial of 4. 4, 3, 2, 1. Okay, again, use your calculator. I'm going to go ahead and do 4 times 3 is 12. So that cancels out that 12. And then 2 goes into 14 7 times. So what I'm left with on the top is 15 times 7 times 13. And that gives me 1,365. Okay, so just out of 15 kids, there are 1,365 different groups of 4 that I could make. Okay, there are 12 people in the class, and I'm giving prizes for the first and second favorite students. First and second place favorite students. How many ways can I pick a first favorite and a second favorite? Okay, does the order that I pick them in matter? Oops. Yes, the order is important, okay, because, hold on, let me write this. That makes it a permutation. If I said, well, my first favorite is Bella and my second favorite is, I'm thinking of y'all's names without a class list in front of me. I love all of you, but I cannot keep track who's in what class. Okay, if I pick Bella and then Courtney, is that different than saying Courtney and then Bella? Yes, because the order is important, right? One is my first favorite, one is my second. There's 12 in the class, so this is just 12P2, right? The order is important. I'm not getting rid of duplicate groups. So this is just 12 times 11. I'm not doing any division, which is 132. Okay, couple more. Express each probability as a simplified fraction. First of all, for me personally, with these kind of spinners, I like to write it out. Okay, otherwise I get confused. So I know I have snakes, sharks, squirrels, and spiders. Okay, so I have snake, shark, squirrel, snake, spider, squirrel. Okay, so I should have 8 sections, right? 1, 2, 3, 4, 5, 6, 7, 8. 3, 2, 2, and 1 is 8. So I know I have everything accounted for. It's just easier for me personally to keep track of this. So what's the probability that I spin it once and land on squirrels? Okay, well that's 2 out of 8, which is 1 over 4. Okay, and that's it. What's the chance that I spin it once and land on sharks? Again, that's 2 out of 8, which is 1 out of 4. What's the probability that I spin twice, landing on snakes the first time? So snakes is 3 out of 8. And squirrels the second. Well, squirrels is, I already did it up here, 1 over 4. So 3 times 1 is 3. 8 times 4 is 32. Okay, what's the chance that I spin twice and land on sharks both times? So the probability of sharks is 1/4. The second time I spin it, the probability is still 1/4. So that's 1 over 16. And then 34, spinning twice and landing on squirrels. Well, that's 1/4. And then snakes is 3 out of 8. So that's 3 out of 32. Okay, how many ways can I arrange 4 kids for a group picture? Okay, is the order important? Yes, it literally says I'm arranging them, right? So how many different ways can I do it? Well, there's a couple different ways you can think of it. You could think of I have 4 kids and I'm arranging all 4 of them. And that's the same thing as 4 factorial, right? Which would be 24. So I have 4 kids who could come first. And I pick student A. So I have 3 choices left, right? Then 2, then 1. I'm arranging all of them. Okay, you're at a pizza parlor and you are picking 4 toppings off a list of 9 for your pizza. How many different pizzas can you make? Does the order matter? If I say pepperoni, mushroom, sausage, onion, is that the same as onion, sausage, pepperoni, mushroom? I think I've said the same before. Yes, it's the same. It's the same group. That tells us this is a combination. So that's 9C4. So 9, 8, 7, 6, because I'm making 4 choices starting with 9, divided by the factorial of 4. 4, 3, 2, 1. Okay, I'm going to go ahead and say 4 times 2 is 8. So those are gone. And then 3 goes into 6 2 times. So now on the top, I'm doing 9 times 7, which is 63. And then 63 times 2, which is 126. So I'm going to double check it. So 9 times 7 times 2. Yes. Okay, and you don't have to reduce. I could have done 9 times 8 times 7 times 6 divided by, and then I know 4 times 3 times 2 times 1 is 24. And I got the same answer. Okay, so again, if you have questions, come to today's Zoom call. You can ask me there. We'll work them out live. Send me an email, but Zoom, again, I think would be the best, or Flipgrid.